Section 4.1 Composite Functions Part 2. Example 3. Suppose you're given a composite function 1 over square root of x plus 4 minus 5. Find a possible f of x and g of x. What does this mean? Well, we know that we plugged in g of x into f of x to get h of x. So what could have been a parent function or the main function we're plugging into? If you said 1 over x minus 5, then you are correct. Think of this as 1 over x minus 5. What did we plug into 1 over x minus 5 to get 1 over square root x plus 4 minus 5? Well, if you said square root of x plus 4, you are correct. So this is our final answer, but I'm just going to do the composite function so you can see what that looks like. So we have f of g of x, right? And this is our h of x. Well, g of x, so right now I'm just checking my work. G of x is square root of x plus 4. Remember, work your way inside out, okay? And then we're going to plug in the square root of x plus 4 into the f function. So that gives me 1 over square root of x plus 4 minus 5. So that is correct. That is my h of x. Now let's move on to the domain of the composite function. Now this is tricky because I can't just look at the domain of the composite function. I actually also have to look at the domain of g of x. So the domain of the composite function is where f of x and g of x, f of g of x and g of x overlap. And we're going to take a look at an example. So look at example 4. We are given two functions, 2 over x minus 3 and 3 over x plus 1. Okay. The first thing I'm going to do is I'm going to look at g of x. So we're in step 1. So let's go ahead and find the domain of g. So we already know how to do that. A rational function is defined everywhere except where x plus 1 equals 0. So I'm trying to figure out where is that. Therefore, x cannot equal negative 1, because if x equals negative 1, we get 0 in the denominator. And I'm just going to write my domain in interval notation. For step 2, let's go ahead and find f of g of x. So again, we're plugging in the g of x into the f function. Okay, so here's my g of x, and I'm plugging that into the x value for the f function. And we get 2 over 3 over x plus 1 minus 3. Now, in order to simplify this, you need to find the common denominator, and then you multiply by the reciprocal. But there is a shorter way to do that. All I have to do is multiply top and bottom by the lowest common denominator so that all my denominators cancel out. Since I only have one denominator in the bottom, which is x plus 1, I'm going to multiply top and bottom by x plus 1. Okay, and then go ahead and distribute the x plus 1. So if I distribute the x plus 1 in the bottom, the x plus 1 cancels in the first term, and we get 3 minus 3 times x plus 1. And that's a shorter way to do things. But you don't have to do this way. If you're used to the long way, go ahead and do it that way. And then just simplify. So now I have my f of g of x function. Now again, remember, this is a rational function, and therefore your denominator cannot equal 0. So let's go ahead and find where our denominator equals 0. Well, that's at x equals 0. Therefore, x cannot equal 0. And our domain is from negative infinity to 0, union 0 to infinity. We're almost done. Okay, so now what we have to do is we have to see where the domain of step 1 overlaps with the domain of step 2, and that's going to be our final answer. So I drew my domain from step 1 on a number line, as you can see. And then I'm also going to draw my domain from step 2 on a number line. This just helps me visualize where our answers overlap. So only include the intervals that overlap from step 1 and step 2. And that is negative infinity to negative 1. I have to stop at negative 1 since for the g function, negative 1 is not included. Union negative 1 to 0. since for the f of g of x, 0 is not included. And then finally, union 0 to infinity. Now, see if you can do example 5. Again, press pause and try to do that one before you see how I do this problem. Again, we're going to start with the domain of g of x. So we have x plus 4 has to be greater than or equal to 0 since we have an even root. Okay, and then solve x greater than or equal to negative 4. And then I just wrote my domain in interval notation. For step 2, we're going to find f of g of x. And then we know the bottom cannot equal 0, so we're trying to find where it is equal to 0. And that is at x equals 0. Therefore, our domain is defined everywhere except at x equals 0. And then I just wrote it in interval notation. And then I'm going to do the same thing I did above. I'm just going to write our answers or draw a number line and put our answers there because it's easier to visualize and see where these overlap. So as you can see, the negative infinity to negative 4 is not going to be included since it doesn't overlap with our first answer. And then our domain is, it starts at negative 4, goes all the way to 0. We cannot include 0. And then union 0 to infinity. And that is pretty much it for this section. Thank you. Have a great day.